Hi, my name is Kornoga, and I want to tell you about the process matrix, which can hold the breast cancer knowledge and is inside the QRGBS. So this is the tool into which we have to document the knowledge of breast cancer treatment. So, and I would like to show you how the tool works, or how the model works, and how it is different from process matrix, which so far has been the only model working in all workflow machines so far, how it is different and why it can hold all the breast cancer treatment knowledge. First of all, the process matrix is, as you might know, a tool that resides in the quadrant of high problem complexity and high solution complexity at the same time. So it combines many rules and many variants, which is the breast cancer, with many steps and many actors, which is the treatment for breast cancer. And so far, the flowchart has been the only tool in all workflow machines, and that tool has the limit of 7 problem description variables or solution variables and 24 activities, and that is not enough for breast cancer treatment. So the model I'm about to explain is the process matrix. It includes the flowchart as a special example, but it extends it widely. And we are the only company that has a workflow engine that has the process matrix as its model. All the competitors have either flowchart or project management tools or diagnosis tools or rule engines alone, without the ability to devise a project and update it on the run. A major example is Watson. IBM Watson is a diagnosis tool which is quite good at what it does, but it doesn't do the planning of the treatment and updating of the treatment as you go. That is what we do, and that is what the process matrix does, and that is what only we do, only we. So in order to explain the benefits of going there to the process matrix, I'll go through 4 dimensions of it, or 4 groups of columns. And first of all, it allows you to switch language to many other than English. And while everybody sees the same process, but in different languages. So you can have a patient seeing the whole thing in Spanish while you treat the patient in English, and you see the same treatment. Then there's the workflow. It scales with the complexity. So that is the fact that it can run on unlimited or almost unlimited amount of complexity, such as the breast cancer. Whereas the flowchart has no ability to scale. It is almost exponential, so it is impossible to scale beyond 7 decision variables. It avoids bottlenecks that aren't in the rules, so you can do things in any sequence that you want, provided it is allowed. It gives freedom to navigate back and forth, and that is what doctors want. So they want to set the dose of chemotherapy and order it before they have a final determination of all the things that go into it. So if something changes that determines something that you have already completed, then it will ask you to redo the decision automatically. So you can never make an error, even though you get wiser on the basis of the decision you have already made that was correct when you made it. Therefore, you have the freedom to navigate back and forth, and that is quite important in the treatment. Then it has a track and trace, in that you can trace everybody who is in it and find out what decision they've made based on what knowledge. And the non-executors, like loved ones, can follow the process as well without being able to edit anything in it other than consents, etc. So you can allow many people to see the same process at the same time. Then it allows chaotic working, like the one I just described, where you can step back and forth, and it will still keep order in everything you do. Then for the data, it's intelligent and instant. It appears only when relevant, and you only have to set values that have a meaning in your particular version of the flow. Otherwise, those will disappear, and it resets data as you go. It has a lot of derived calculations, and it derives them instantly, or you can call it cascaded data, in that you have height and weight, and from which you calculate the body mass index. But you have a lot of cascades happening downstream, sometimes several, like comorbidity scores, and a lot of derived data from original data, and it recalculates all the time whenever you change an ingredient into a formula. So it makes it possible to do data-driven decisions on different levels of data. And the listener structure inside the machine makes sure that it's always updated. And as a consequence, when you have to reset a decision or redo a decision, it forces you to redo it whenever something that goes into that decision is changed. Finally, it can do external integrations, like to Epic or other EHR systems, and they can be determined by script, by a lot of other code options. And therefore, since these integrations happen on a point base or on an activity by activity basis, they can be debugged and made sure that they are correct without reviewing the whole solution. You only have to review that particular step, which has that particular integration. It makes it much more secure to run on top of a complex system. The way it works is shown here. It has activities, roles, states, and data. And for each activity, it has a number of letters, which includes which roles are on this step, which states are evaluated and determine that step, and which data goes into that step. And at the bottom, you see all the many labels, etc., in different languages. So on the left, you have the activities, and it can be, as shown here, the post-operative assessment and adjuvant theory planning, which comes in two groups: predictive factors and adjuvant therapy planning. And one of the adjuvant therapy planning activities can be consider the adjuvant therapy after surgery 6.2.1. That's one activity out of 250. And if you follow that row out, you'll see what that activity contains. This is a bit dirty, but you have 250 plus activities and 300 plus decision points, as mentioned before. And then you have data elements behind all those decision points. They may determine the decisions or just be there as data that is important to hold in that flow, like weight, height, etc. And then it determines everything from that. As an example, we have the same flow chart to the top left, expressed as a process matrix to the top bottom right. So each activity in the flow chart is diagrammed as a box. Here, application is one activity, and you see it here as one row. You see that the applicant is the role active in the application, and you see it here because it has an execute role for the applicant for that row and nothing for the others. You then see that it sets the variable rich and the variable hurry and the variable application account. Excuse me. Then the next activity is case processing. You see case processing here. It has a predecessor of application or activity number 1. It is executed by the caseworker, which you see here in the flowchart. Excuse me, etc. So everything you have here is here as well. And then if you extend it, you can do a lot more than you could in the flowchart, but the flowchart is a special case inside the process matrix. That's what I wanted to show here. How the process matrix works. First, the activities. are to the left, and they are in a hierarchy, and they have predecessor relations, which have the same meaning as the arrows in the flowchart, but they are more advanced in those arrows in that they can be partitioned in logical and sequence. There are freeze conditions, etc. They can be mapped to more than one role, but in this case, just one role, which is what we show here. It's mapped to the applicant. It can have a reset condition, etc. And then it can have many languages to show the labels. And then the N and Y part in the green area will show you whether to show that activity or not. So it has the same role as the routing inside the process matrix. It's just more advanced. Then we have a data model, which consists of two parts, the states, which are green, and the other data, which are red. Inside the data matrix, or part of the matrix, you can have a type. It's always Boolean when it comes to state, because they can only be yes and no. And the rest of the data can be text, integer, double, amount, code values, with reference to which code values are allowed on that particular code value, files, extracts, text, etc. So the name, for simplicity, will determine which type the data element is. Then it has a relevance condition, which is used to show that data element or not. It has a prefill formula in that you can determine how it should, how the data should be computed from other data, and then it has listeners on that other data automatically, so that whenever that other data is changed, it recomputes the prefill formula. It also has script formula. I'll not go into the script inclusion, but we can include C# scripts edited in Visual Studio on each step. And if we do so, the script formula mean or have a communication between the scripts and the value of the data model. And there are a lot of other things. Finally, we have roles in the blue part, which, if taken from a flowchart, there's only one per row, one role per row, but we can have more, and they can have different rights. Like execute means you can execute that particular step. If it has only a role where you can just follow it, then that role is typically the right is typically assigned to loved ones, because they are not allowed to execute the step but allowed to see it. And then if we deny a particular step because that step must not be shown to loved ones or to the patient himself, etc., then we can also determine that in the role part of the matrix. So that's the explanation behind all this big 300 by 250 diagram. If we elaborate or if we expand the left-hand part of it, we've only expanded one. If we expand them all, we get to this. Remember that underneath each line here, there are several activities. So these are just the groups inside the phases. So you can see the more than 300 steps there, of which 250 go into the treatment plan for any patient. And then the data elements in groups as well. There are more than 300 state variables, for instance, but they are grouped like the one or the set of groups you see to the left here. And all the other data is grouped like you see to the right here in the red part. So there are more than 300 state variables in those groups, and there are more than 1,500 variables in those red groups. Just as an example of the cascaded data, you can see it here. There's a state variable called mastectomy recommended. It has a prefill formula of many ingredients, and if any of them they have this Boolean formula saying if this and not this and not this, and not this, etc., then it's false, otherwise it is true. That in itself, tumor above threshold indicator, is a variable, and that variable has a formula which you can see here. It's tumor diameter millimeter more than a threshold, then it's true, otherwise it's false. And that threshold is again a variable which has the formula of 40. So what you see here is if the tumor is more than 40, then this is true, and this part of the equation is true, and then we find out whether we recommend a mastectomy, etc. This is just one of the many formula in the matrix shown. And you can see how it works here. It's the 40 appear here in the threshold, and it's the view of what you see in the solution is generated from the matrix in this way. First of all, you look at the line decision of kind of surgery. That's the same line that's selected over here, and the G's and indeed the other letters inside the matrix determine which data elements are included on that step. And you can see that the 12 is the tumor diameter in millimeters that's included here. And those four variables, three of which are Booleans and one of which is a code variable, those four variables are here, 3 Booleans and 1 code variable, and they are included here. And the render in between them, there are 2 other variables. You see them here, the tumor diameter and the threshold of the tumor diameter. So the point in showing all this is that the forms in that huge flow are generated, all of them, from the matrix and from the underlying data model. And of course, the activities are generated from the activity part of the process matrix, and you see the labels in English here. So this is an example of how the process matrix with more than 250 activities and more than, in this case, 1500 data elements, 300 decision variables, generate the solution and make sure that the rules in the matrix are also the rules of the solution. And this concludes my presentation of how the process matrix works. I hope you enjoyed it. Thank you for listening.